Here are your video notes for lesson 6.5, and lesson 6.5 is about solving special types of linear systems. So if you'll get that copy down with us. If we take a look at what your book has to offer, lesson 6.5 here says that you found the solution to linear systems before doing this section, and the way you found solutions, there was three methods to finding these. You did it by graphing, learned how to do it by substitution, that's where we put one equation into the other, and you did it by elimination, that's where we either added or were subtracting the two equations. And now that we have done that, what you're going to look at doing today is you will identify the number of solutions of a linear system, and you'll learn some kind of difficult sounding vocabulary words here with inconsistent system and a consistent dependent system. You'll learn what those are. So if we remove some stuff here, we'll get going with an example. We pull this up from the bottom here for our first example. Would you copy this down with me, please? We have example 1, 2x minus y equals negative 2, and the other equation we'll look at is y equals 2x plus 4. Let's go through and solve this first system by elimination, because that's the most recent thing we've covered. And I'm going to adjust the second equation so that we have it written in what's called standard form. And I'm going to take this now and I'm going to move it up there to place under that one, and I'll have negative 2x plus y equals 4. And now I am ready to add these together because I see I have 2x and negative 2x. I like that because that's going to give me 0. Then if I come over here, I have a negative y and a positive y. When I add those together, that gives me a 0 too. So on this side of the equation I have 0. Both variables have disappeared. I'm going to bring my equal sign down, and my negative 2 combined with my 4 is going to give me a positive 2. And this right here presents a problem. Can 0 equal 2? No, that's something that's impossible. So since that's impossible, we're going to end up calling this that this is an inconsistent system. And an inconsistent system is a system in which there are no solutions. And another way to think of this is that this is a false statement, and since that is false, we have seen other times that this has no solution. Probably the best thing we can do for your understanding of why this has no solution, do not worry about trying to copy this down with me, but we'll take a look at what would this be if we did graph it. And if we were graphing this, if we were to take a look at this equation, we can already graph that because that's already in what's called slope-intercept form. We should know that our intercept, or y-intercept, is 4, so if I put a dot here at 4, then we should know that we have a slope of 2, which means now if I went up 1, 2, and over 1, I'd get another dot on the line, but I'm right off the graph. If I go backwards and go down 1, 2, and back, I will get another graph on the line. And I could keep doing that and get another dot and get another dot. So the graph of my line here would look like this. Now if I take a look at the other equation is not in slope-intercept form. It is that 2x minus y equals negative 2. Which we could change to slope-intercept form if we wanted, or we could look at it and graph it by finding the intercepts. And I could find the intercepts fairly easy with this. For finding the y-intercept, I would want to put 0 in for x right here, and if I put 0 in for x, I would get that negative y equals negative 2, so y equals 2. I'm going to put a dot here at y equals 2. To find the x-intercept, I would want to put 0 in for y right there, which would give me that 2x equals negative 2, and when I divide both sides by 2, I would get that x equals negative 1. So if I plot a point at -1, I would end up seeing that these two lines run parallel to each other, and that is what's giving us where these two lines will never cross and therefore give us no solution ever. If you would like to see a quick explanation on how I found those intercepts for review, I'll bring that in for you. This would have been the work. This is where I put 0 in for x, so it eliminated. I divided both sides by 2, divided both sides by 2, and got x equals -1. Or I could put the 0 in for x, and if I put the 0 in here, 2 times 0 is really 0 minus y, which we don't need to write, so -y equals -2 and y equals +2. Remember, you don't have to be showing the work of graphing any of these. The point of the graph is for you to see why there is no solution. We've got two lines running parallel to each other that will never intersect. If we move forward here and look at example 2, if you'll copy this down with me now, we have, for example 2, that 4x minus 2y equals 8. We have y equals 2x minus 4 for other equation. And if we were to look at solving these, since this second equation is already solved for y, we can take this and substitute it in for y over here. This would be review of the method of substitution. So I will have 4 times x minus 2 times, putting the y part in, we will have 2 times 2x minus 4 here is equal to 8. And now we will have 4x minus, and if we distribute this, we will get minus 4x plus 8 equals 8. And if we subtract 8 from both sides, we will get 0 on this side. That will be gone. And by combining our like terms of 4x and -4x, the result of that will give us 0 on this side. And now we have our variables have both disappeared. But the result of what we have here now actually is this is a true statement. 0 does equal 0. And just like another type of equations that we had, when we get a true statement, this is going to indicate to us that we have infinitely many solutions. And this type of thing is what's called a consistent dependent system. Consistent dependent systems have infinitely many solutions. Now you should have that much copy down with me again. You don't need to copy down the stuff I'm going to do for graphing right now. But the graph will show us why we have infinitely many solutions here. For the first equation that we had here, if we go through graphing that, we know we have a y-intercept of -4, and we have a slope of 2, which means we're going up 2 over 1, up 2 over 1. Here is our line that we are graphing for that. If we were to graph the other equation, if we were to put 0 in for x, we will get the equation -2y equals 8, and dividing both sides by -2, we will get -4 for our y-intercept. And if we put the 0 in for the y variable here, we will get 4x equals 8. And when we divide by 4 on both sides, we get the x-intercept to be 2. And what you'll notice is that means this line lies right on top of the other one. Another word for that the book will use is the two lines coincide. And another method that we could have used to have graphed this would have been to change this equation, the 4x minus 2y equals 8, into slope-intercept form, where we would have subtracted 4x from both sides, gotten -2y equals -4x plus 8, dividing by a negative 2 and dividing this side by a negative 2, we would have ended up with y equals negative 2x minus, sorry, this should have been a negative 4, so that would be a positive 2x minus 4, and you would see this equation is the exact same as this equation, and you would have known that the two lines are basically, or are the same line, so that they lie right on top of one another and give us infinitely many solutions. If we move ahead to a last example to look at, another type of problem that we will have, we'll say without solving, tell how many solutions. Okay, so without actually solving this, tell how many solutions that this system would have. And the book has a nice summary of what's been going on for this whole thing here. And this is found on page 406 of your book if you wanted to be able to know where to find that. But if you have one solution, you have to have two lines crossing, and in order to have two lines crossing and have the one solution, the two lines must have different slopes. If you have no solutions, you have to have two lines that are parallel. In order for the two lines to be parallel, the lines have to have the same slope, but they have to have different y-intercepts to be two different lines. And then in order to have infinitely many solutions, the two lines have to coincide, or one has to lie right on top of the other. In order for that to happen, the lines have to have the same slope and the same y-intercept. So with that in mind, if you can look at these equations and change them into your head so that you would have this one solved for y, which I know in order to get there it's going to end up becoming y equals negative 5x minus 2, and then solve this equation for y. And some of you will be better at this than others, and some of you, I would say, should be showing your work. I'll go back and show the work in a minute. But if we could end up saying that y equals, this is going to turn into negative 5x minus 2 as well, you'd see you have the same two equations, and by comparing the slopes, both slopes being negative 5, you know that this is one of the two special cases of either having no solutions or else having infinitely many. And then when you go on to compare the two y-intercepts, this being a negative 2 and this being a negative 2, you know, these two lines lay right on top of one another, and your answer for this, as far as telling how many solutions it has, it would have infinitely many solutions. Now, if you're not able to go through and solve those in your head, as I've done, which many of you would need to probably go through and show the work, what was really getting done there was subtracting 5x from both sides, bringing down the y, bringing down the minus 5x, and then bringing down the minus 2. Here, it involved adding on 10x to both sides, getting negative 2y equals 10x plus 4, and then dividing by a negative 2 on both sides, where when we divide the 10x by negative 2, we got the negative 5, and when we divided the 4 by negative 2, we got negative 2. So if you need to show your work for those that tell you to tell how many solutions without solving, show your work on those. Otherwise, we'll see you in class tomorrow and get you started on your assignment.